Hey everyone, welcome back to our channel. If you're passionate about machine learning or just curious about how it all works, you've clicked on the right video. Today, we're diving deep into a fascinating technique called stacking. So, whether you're a beginner or someone with a bit of experience, stick around because we're breaking it all down in simple terms. Now, you might be wondering, what exactly is stacking, and why is it important in machine learning? Well, that's a great question. Let's explore this powerful ensemble learning technique together. So, first things first, what is stacking? Stacking, or stack generalization, is a method used in machine learning to combine multiple models to improve overall performance. The basic idea is to take predictions from various models and use them as input for a new model, often called a metamodel or blender. This metamodel learns how to best combine the predictions from the base models to produce a final prediction. Imagine you have three different models: Model A, Model B, and Model C. Each of these models has its strengths and weaknesses, and they may make different predictions based on the same data. Instead of choosing just one, stacking allows us to leverage the unique insights from all three to make a more accurate prediction. Here's an example to clarify things a bit. Let's say you're working on a project to predict house prices based on features like location, size, and number of bedrooms. You train three different algorithms: a linear regression model, a decision tree, and a support vector machine. Each of these models makes its own predictions for house prices. Now, rather than just going with one model, you can take the predictions from each of these models and feed them into a fourth model, a metamodel. This could be another regression model or even a neural network. The metamodel learns from the predictions of the three base models and finds the best way to combine them to produce a final, more accurate prediction. Let's talk a bit about how stacking works under the hood. The process typically involves two main phases. The first phase is where we train our base models, and the second phase is where we train our metamodel. Here's how it usually goes down. 1. Train base models. You split your dataset into two parts. The first part is used to train your base models. Each of these models will learn from the data independently. 2. Generate predictions. Using the second part of the dataset, you make predictions with each of the base models. This is important because we want to ensure that the predictions are made on unseen data to avoid overfitting. 3. Create a new dataset. Now, you take those predictions and create a new dataset that will be used to train the metamodel. This dataset consists of the predictions from the base models as features and the actual target values as labels. For train the metamodel, finally, you train your metamodel on this new dataset, allowing it to learn how to best combine the predictions from the base models. The beauty of stacking lies in its ability to capture the strengths of various models while mitigating their weaknesses. For instance, if one model struggles with certain types of data, the metamodel can learn to trust the other models that perform better in those scenarios. To see stacking in action, let's take a look at a real-world application: Kaggle competitions. Many data scientists and machine learning practitioners use stacking to improve their predictive models and climb the leaderboards. In fact, some of the top-performing solutions in these competitions often involve advanced stacking techniques, combining a diverse array of models to achieve remarkable results. Now, you may be asking yourself, how can I implement stacking in my own projects? There are several libraries available in Python, such as scikit-learn and H2O.ai, that make it quite easy to experiment with stacking. In fact, why not try it out on your next machine learning project? You may be surprised by the results. To wrap things up, stacking is an incredibly powerful technique in machine learning that allows us to combine the predictions of multiple models to enhance accuracy. By leveraging the strengths of different algorithms, we can create a robust model that performs better than any single model could on its own. If you found this video helpful, please give it a thumbs up and consider subscribing for more insights into the world of machine learning. And hey, if you have any questions or if you've tried stacking in your own projects, drop a comment below. We'd love to hear from you. Thanks for watching, and until next time, keep learning and exploring.